Hey guys, what's up? So today we're going to be looking at the sector of a circle, okay? And it says here the sector of a circle is defined by two radii, right? Meaning two radius. So two radius, okay? One right here and one right here. Cool? Just like in this example, one right here and one right here. Cool? Now, these two radii separate two sectors, okay? So as you can see here, there's a minor sector here and there's a major sector here, okay? And the major sector is clearly bigger than the minor sector. And we also have a minor arc, which is from here to here, and the major arc, which is from here all the way around to here. Cool? All right, so it's pretty simple to understand, okay? And it says normally we have a minor sector and a major sector of a circle. Cool, just like in this example, except when both sectors are semicircles. So in the case where it's a semicircle, guys, meaning that the angle is 180 degrees right here around the center, then in this case we don't have a major or minor sector because both of the sectors are equal, okay? So we also have the major arc and the minor arc being defined at the circumference of the circle. Okay, so basically what the major and minor arc are, when you add them both, you get the circumference, but one is a smaller part of the circumference and one is a bigger part of the circumference. Okay. All right, guys. So when you look here, we're looking here at the minor sector of the circle right here, and this is a close-up view of it right here. And it says here that the area of the sector A is equal to pi r squared times how many degrees are there for that minor sector over 360. Right, and that's exactly what it is. Pi r squared times how many degrees in the minor sector over the 360, right? So for example, guys, if we wanted the area for the major sector, right, we would need the degrees or the degree amount theta for the major sector, okay? So for example, let's say the minor sector is 60 degrees and the major sector is 300 degrees, right? Clearly we would put 60 degrees here for the minor part and we'd put 300 degrees here for the major part to find the area, okay? Now to find the length, okay, which is the L here, where L is the length of the arc. To find the length of the arc, meaning the minor arc or the major arc, all we would have to do is multiply 2 by pi by r and multiply it by how many degrees for that arc over 360 degrees. Cool? Now, it's the same thing, guys. For the minor arc, right? For the minor arc, all we have to do is put 60 degrees over 360, then multiply it by 2 pi r. And for the major arc, all we have to do is multiply 300 degrees over 360 by 2 pi r. So we're able to find the major and minor sector and the major and minor arc, okay, using these formulas. And it says here where L is the length of the arc, R is the radius, and this symbol here, guys, is called theta, right? Theta degrees is equal to the sector angle in degrees, okay? So this is whatever the angle is for whatever you need to find, okay? All right, so it's a little confusing, but don't let it confuse you. All right, guys, so we'll have the formulas here. And as usual, once we have the formulas, we can dive into some examples, okay? And once we start to do some examples, everything will become clearer and we'll be able to solve problems with this situation very easily, okay? All right, so let's look at some problems right away, okay? All right, guys, so we're looking at an example here. And it says, given the information above, find the area of the major sector and the length of the major arc, okay? So we can see here that for the major sector, here is the major sector, right? Right in here is the major sector. And we can see that the degrees, the amount for the major sector is actually 300 degrees, right, for theta. And the radius is equal to 4 centimeters. Cool. So that's pretty much all we need, guys, to find the area of the major sector and the length of the major sector. Okay. So first thing we're going to do is find the area of the major sector. And we're going to let pi equal to 3.142. All right, guys. And so we're going to say pi r squared multiplied by, in this case, it's 300 degrees over 360 degrees. Cool. So we're going to get 3.142 multiplied by multiplied by r, which is 4 centimeters squared, multiplied by 300 over 360. Cool. So for the area now, we should just put this in our calculators, and we should end up with 41.89. Right, I left my answer in 2 decimal places, 41.89 centimeters squared, right? Because the area is in centimeters squared. All right, guys. Cool. So let's find the length as well. So we found the area. Now we need to find the length. So we're going to use the formula for the length. It's equal to 2 pi r times theta over 360, right? So in this case, it's going to be 2 times 3.142 times r, which is 4 centimeters, multiplied by 300 over 360, right? All right, so we just need to work that out now. We're going to put that in our calculators, guys. And what do we get for L? Right, so the answer for L should be equal to 2.95 centimeters. Okay, so that's the answer for L. Great, so we did number 1, guys. Let's move on to another example. Okay, guys? Okay, guys, so we're looking at number 2 now. We're looking at the second question with the sector of a circle. And it says, given the information above, find the minor sector of the circle and the length of PQ. And if you can see here, the length of PQ they're referring to is P, this point, to Q here, right? Which is just L, the length, right? Okay, so all we have to do now to find the area of the minor sector, we see that theta is 60 degrees in the minor sector there. So all we have to do is say pi r squared multiplied by theta over 360 degrees. And in this case, theta is 60 degrees, right? So we're going to say 3.142 multiplied by r. In this case, the radius is 5 meters. So it's 5 meters squared multiplied by 60 over 360. Cool. All right, so let's just put that in our calculators right now and see what we get. All right, and the answer we should get should be 13.09 to 2 decimal places, and this should be in meters squared. All right, guys. Cool. All right, so let's find the length of PQ. Let's find the length of PQ, and L should be equal to 2 pi r times 60 over 360 in this case, right? So it should be 2 times 3.142 times 60 over 360, all right? And we're going to put that in our calculators, guys, and we should get 5.24 meters, all right, guys? So this is actually the length of PQ, all right? Cool. So all right, so let's do one more example, guys. Just one more, guys. All right, guys, so we're looking at number 3, and this example, it says, given the information above, calculate RS, which is the length here for the minor arc, okay, for the minor arc here. And it says calculate the area of the major sector, which is here, Okay, so this question incorporates both. So we'll have to think about this one, guys. So for the minor arc, right, we need to calculate RS, and RS should be equal to the length here, which is 2 pi r multiplied by theta, which is the 45 degrees in this case, because we're trying to find the minor length, which is just r to s, right, over 360 degrees. All right. So the length of RS should be equal to 2 times 3.142 times, in this case, the radius is 7 millimeters, multiplied by 45 over 360. All right. So the length, guys, we should just put that in our calculators, and our answer should be 5.50 millimeters squared. Cool. And the second part of the question says calculate the area of the major sector, right, guys? And in this case, if the minor sector's degrees, right, if theta in the minor sector is 45 degrees, then clearly out here is 315 degrees, okay? Meaning right here, the angle here should be 315 degrees. So to find the major sector, we have to multiply pi by r squared times 315 degrees over 360, right? Because we're not trying to find the minor sector here, we're trying to find the major sector on the outside, the big sector, right? So we're going to end up with 3.142 multiplied by 7 millimeters squared multiplied by 315 over 360, okay? All right, guys, so we can just put that in our calculator now, and we should get 134.71 millimeters squared. All right, guys. Great. And right, the length of RS should not be millimeters squared. It should just be millimeters, right? Because for the length, we're not squaring anything, so we really shouldn't get millimeters squared for the length. So we should get 5.5 for the length of RS, and we should get 134.71 millimeters squared for the area of the major sector. All right, guys, great. So we'll finish the 3 examples, and all we need to do now is move on. All right, guys, I'll see you in the next lecture. All right, guys, so that's it, and I'll see you in the next lecture, and remember to do your best, and God will do the rest.